Hello everyone and welcome back to Arduino Lab GH. Today I am bringing you a very interesting project. The idea came to me a few videos ago when I recovered some parts from broken servo motors. If you missed the video, I will leave the link in the description for you to check it out. As I mentioned, I salvaged parts and housings from various servo motors, and after looking at the materials, I decided to create something unique. I chose the housing from an MG966R servo and a micro motor from an MG90S. This is how the servo motor's clock was born. It is a detailed project, not necessarily because of its complexity, but because of the small scale. Integrating all the components into such a tiny space takes time and precision, but the result is a very beautiful and unique style that you have never seen before. This project was a challenge to see what can be achieved through recycling, giving new life to objects that were destined for the trash. This video will be divided into 4 specific parts. First, the modification of the servo housing. Second, the programming phase. Third, the electronics in assembly. And finally, the demonstration of the finished project. For this project, I decided to use the ESP-1 as the brain. I chose this specific board because it has only 8 pins and is extremely small, making it the perfect fit for the interior of our servo housing. Despite its size, it has all the features we need, including integrated Wi-Fi. To display our data, I am using a small OLED display measuring approximately 2 by 1.5 centimeters. Now we will move to the computer to upload the code. To perform this operation, I will use the ESP-1 programmer that I built in my previous video. If you missed that build, I will leave the link in the description so you can see how it was made. Here we are at the computer. We connect the USB cable to the programmer. Our ESP-1 is already placed in its slot. In the software, we select the correct board, which in this case is a generic ESP8266 module, and choose the proper communication port. Now let's verify the code because we need to insert our personal data, the Wi-Fi network name and password for the connection. Next, we load the API keys. The first one is for the weather, used to request data from Open Weather Map for the Berkham area. The second is the YouTube API key, a security code required to communicate with Google servers. Along with this, we will insert our channel ID, the unique identifier that allows the clock to find and display our specific channel statistics. After filling in the data, we upload the firmware. For safety, before installing it into the servo housing, we will test it on a breadboard. In our MLab projects, prototyping on a board is a mandatory step. It guarantees an optimal result and allows me to verify all hardware and software adjustments before the final assembly. I would like to clarify one thing. Anyone who wants to replicate the servo motor's clock but does not have a YouTube channel can easily do so. You just need to enter your Wi-Fi details and the weather API keys for your own city and location. This way, you will still have the correct time, date, and local weather updates. Of course, this project can be installed in any type of housing. The internal micro motor is also optional. I included it to create a mechanical effect that mimics the original movement of a servo. It is purely for aesthetics and is not required for the clock to function. As you have seen from the prototyping phase, everything is working perfectly. Now, let's move on to building the final circuit and the assembly inside the housing. For this project, we will need a 0.96-inch OLED display and a ESP-1 module, a lithium battery, and a charging module. We will also use small pieces of wire for the connections. This is all you need for the simplified version. For the full project, you will also need a BC547 transistor, a 1K ohm resistor, a 1N4148 diode, a micro motor, an NG966R servo housing, and a case for the battery and charger. The transistor, resistor, and diode are used to drive the small motor, which will click every second to simulate the mechanical movement of a real servo. The wiring is very simple, and as always, I will leave the connection diagram in the description. The only challenge will be fitting everything inside the small servo housing, but with a little patience it can be done. In the video, you will see all the steps. I haven't cut anything, I only sped up some parts to keep the video concise, so you can clearly see every stage of the assembly. We are almost at the end of this project. As you have seen, the connections are very simple. The most labor-intensive part was arranging everything correctly to fit inside the small housing. I created the necessary space for the motor, making sure that no components touch each other to prevent short circuits or malfunctions. For mounting and insulation, I used hot glue, which provides a strong hold and excellent insulation for the wires and solder joints. Between the display and the motor, I also inserted a small piece of cardboard as a protective barrier. Even though there was enough space, it is always better to prevent any contact. I used the original wires and connector from the servo to keep the look authentic. I attached a male header strip protruding from the housing to connect the standard 3-pin servo cable. Besides the aesthetics, this cable provides the power supply. I only connected the red wire for positive and the brown wire for negative. The yellow wire is just for show and is not connected to anything, but it completes the visual effect. Finally, I attached the original white servo horn to the motor, which is very lightweight and provides a great contrast. The final result is very small, but truly unique and beautiful. To create the housing for the battery and the charging module, I repurposed a black cardboard box and modified it to get the correct shape and size. Now I'm soldering 2 wires to the battery and connecting the charging module. I'm also adding a female header strip for the servo connections. The servo will be placed directly on top of this small box, which will serve as both the battery holder and the support for the servo. I will secure the servo with some hot glue, just like all the other internal components, including the battery, the module and the headers. This ensures the final work remains elegant and clean. As you know, I care deeply about the aesthetics of my projects. If you have any questions or need information regarding the materials, the code, or any other part of the project, please feel free to write in the comments. I will be happy to respond and help you with any issues. Today we have reached the end of this project. I am truly satisfied. Besides the perfect operation and the very attractive design, it is a useful object that I will use in my lab to always have everything at hand. Now the time, date, weather, and the YouTube section. I can see subscribers and views in real time, which is very useful for me. Now we will see the operation and aesthetics of the Servo Motor's clock. As you will notice, when I connect it to the power, it searches for a connection and joins the Wi-Fi. This allows us to have all the data in real time. As you may have noticed, it has no buttons for setup. The configuration is in real time and it retrieves all data from the network, including the time, so that everything is perfectly synchronized and the time is always correct. On the first screen, we will see the time, temperature, and weather conditions. On the second screen, the calendar with day, date, month, and year. On the third screen, my YouTube subscribers and views. You will notice that the top arm also moves and steps to simulate the servo, or we can almost interpret it as the seconds hand of an analog clock. I also took some shots with the light on nearby to show you the overall dimensions of this object, which remains very small. I hope you enjoyed this video, that it was useful, and that it inspires someone to build it. If you do, write it in the comments and send me photos of your project. Contact me and I will give you the details to send them. I say goodbye and thank you. Leave a comment, subscribe to the channel, leave a like and hit the bell icon. If you liked it and want to share it with your friends, I would appreciate it. Thank you and see you in the next video.